Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon for the all audience or all the participants in this room. We will try to discuss about the once new model produced by Rado Institute, namely Alpha Power Generalized Inverse Power Rado Institute Distribution. We have now the new models, the three parameters probability models produced by Rado Institutes, namely Generalized Inverse Power Rado Institute Distribution. Based on the theory alpha power transformation, we will try to give the one more parameter for the Generalized Inverse Power Rado Institute Distribution. So, based on this theory, we are success to create the new models, the four parameters probability models, namely the alpha power generalized inverse power Rado Institute distribution. So that why, if we are try to read the some research article, of course, we will have the new idea how to make the novelty of the one research article by the create the new probability models. Our discussion today, the Rado Institute try to produce the new probability models, namely the four parameters probability models, alpha power, generalized inverse power, Rado Institute distribution. Okay. Based on the one research article, okay, based on the one research article, okay, we try to open the the research article today. This one. Based on the one research articles, normally the alpha power inverted exponentiated Weibull distribution with data explication published on the Journal of the Mathematics and Statistics on the 2024. Based on this research article, especially in the equation 6 and equation 5, equation 6 is mean we are trying to using this theory, we call the theory is the alpha power transformation, to produce the new models with give the one more parameters, alpha. So in this research article, we will try use the small fx or the all density models by a density model of the generalized inverse power Rado Institute distribution. And we are trying to use the big fx or the cumulative or the distribution function by the using the cumulative distribution of the generalized inverse power Rado Institute distribution. We have success to discuss maybe in the more than the 2 times about the what is the generalized inverse power Rado Institute distribution. So for the audience at home or the participants need the more information about the what is the generalized inverse power Rado Institute distribution, please come to the www.radoinstitute.com and you can find in the menu or the tools international research class, you can find the more explanation about the what is the density function or the cumulative distribution of the generalized inverse power Rado Institute distribution. So in this time we will not discuss again what is the generalized inverse power Rado Institute distribution. Okay. Based on this equation 6 and equation 5, we will try to using the new models is the alpha powers generalized inverse power Rado Institute distribution. Okay, let our open our R. Okay, we try to open our R. Okay, like this one. Okay, this data from the second data set like in the table 6. We run our data. This is our data. the second data set based on the second data on the table 6 in the research article. This is our data. So after we have data, we try to using the concept of the alpha power transformation to create the new models alpha powers generalized inverse power Rado institute distribution. For the first time, we will try to run the program, the log likelihood of the generalized alpha power generalized inverse power Rado institute distribution. And then for the other, if you want to know what kind of density function of the alpha power generalized inverse power Rado institute distribution, you just can see the blue one. The blue one, okay, the blue one is the density function of the alpha power generalized inverse power Rado institute distribution, okay. And then we run our models. We run our model, and then we are trying to using the optim to estimate the parameter. We are give the one for parameter 1, the initial value, and the one for the initial value of the parameters 2, and one for the initial value of the parameter 3, and 10 for the parameter 4. So we run our program here. Okay. So we check in the console, so we can find the parameter here. Okay, we paste here. Okay, APG infinite is mean the alpha power generalized inverse power Rado institute distribution. Okay, we have the parameter 1, 1.4, and parameter 2, 15.9, and the parameter 3, 0.2, and parameter 4, 100, blah, blah, blah. Okay, the convergence. So if we want to know this is parameters good or not, we can check by the comparison with the density plot and the cumulative plot. Okay. The density plot is mean if we have the good parameter, of course, our density function can capture the histogram. The cumulative plot is mean if our parameter is good, of course, the cumulative theoretical and the capture of the cumulative models. So the first one, we give name the omega for the parameter 1, theta for the parameter 2, beta for the parameter 3, and alpha for the parameter 4. We run here. So after that, we need the xi. Xi is for the density plot, and the xx for the cumulative plot. Okay. And this one is the theoretical of the cumulative. So this one, the density of the alpha power generalized inverted Rado institute distribution. Okay, this one is a cumulative of the alpha power generalized inverse power Rado institute distribution. Okay, this is for the cumulative one. So we run our program. Okay, we check the density plot and the cumulative plot. Okay, like this one. So you can check here. The models, the new models, namely alpha powers generalized inverse power Rado institute distribution, is the very perfect in the capture of the histogram based on the density plot like this one. And then based on the cumulative plots, there's 4 parameters models, namely the alpha powers generalized, alpha power generalized inverse power Rado institute distribution can capture the cumulative theoretical. So it means the new models produced by the Rado institutes, the 4 parameters models, namely generalized alpha power generalized inverse power Rado institute distribution, is success to modeling using the second data set based on the research article. Okay, our discussion today is a very nice discussion, and then of course always comes to the www.radoinstitute.com to get the new information or the new knowledge about the probability model. Especially you can find the the best coding program to solve the parameter. Okay, see you again. Rado Yendra, Assalamualaikum warahmatullahi wabarakatuh.